lower surface area. Not the most fun nonetheless, as math can be. Ladies and gentlemen, surface area is simply adding the area of all sides together. And the classic example of that would be if you buy your parents the best Christmas present ever, which would happen to be a pair of shoes. And the shoes always come in a shoe box. Not always, but mostly. And of course, you being, well, let's say this box is what? Let's say it's 12 inches by 8 inches by 4 inches. What type of shoes are we buying here, Sam? Huh? Skechers, because old people wear Skechers. Is that right?
Exactly.
Yeah, I do too. I can say it because I do. Or you could call them whatever you want. I don't know. But you, this is the first time you've ever bought a Christmas present for your parents, so you're very excited about this, and you want to wrap it nicely, right, Sam? But you got no wrapping paper, Sam. So what do you have to do? Go buy yourself some wrapping paper. How do you know how much wrapping paper you need? Surface area. Surface area. I know, you buy the great big roll, and then obviously it's going to be enough, but then you waste it. This is how this works. When you see this, it's kind of long and drawn out, children. Okay? Kind of long and drawn out. Basically, all right, you need to write down all the sides and find their areas. Now, there'll be some helpful little hint things. For example, I have a front, the front side, and that would be this side right here. Here's my front. Now, fortunately for you, if you look, when you have any rectangular prism, which this is, the back, which is back here, is exactly the same. So once you find the front, you've also found the back. Right. And then you've got what we call the right side, which is right here. I probably should use a different color. There's my right side. Now, when you do this, you can actually cut a few corners, but most of this would be that. And like with the front, the back is the same. So here on the right side, this left side is also the same. So you've got a right side and a left side. And what am I missing still? Then we have a, ladies and gentlemen, top and a bottom. So here is the top. The word Skechers is written on the top. And then you've got a bottom that is exactly the same. So you need to find the areas of all of those, and then you add those together. Well, if you look at the dimensions, these are all rectangles. So, you know, the front side is a 12 by 8 rectangle. So its area is length times width, 96. The back is the same exact rectangle, so it's going to be 96. How about the dimensions of the right side? Right side is a little smaller rectangle. It's an 8-inch by 4-inch rectangle. So its area is 32. Left side, same exact rectangle, so it's 32. And then you're just left with the top, which is a 12. Okay, did I do that wrong? I'm sorry, I did. This was the top. This should have been, the front side should have been 12 by 4. So that makes these 48, sorry. Working too close. And then the top would be the biggest rectangle because it is the 12 by 8 rectangle. And that's where the 96s come in. And then your total surface area, TSA, would be all of those added together. Which would be what? It's not too bad. 10, 20, 32. What's that? 8, 9, 10, 11, 14, 17, 26, 332. And these are in square whatever, square inches. So you'd have to go to the roll of wrapping paper that will tell you how many square inches are on the roll. Does the roll of wrapping paper tell you that, Brady? It sure does. It'll tell you square inches or square feet. By the way, how many square inches are in a square foot, Brady?
140.
Thank you very much, yes. So what a square foot, how many square feet are you going to need to wrap this box? Well, you're going to have to tell me. You probably have to buy it and whatever. So will 2 square feet be enough? No. Will 3 square feet be enough? Yes. Let's just go with that. Now, we have one big long other thing here. Now, take out a blank piece of paper because to complicate matters a little bit more along these same lines, we also have something that is called lateral surface area. Lateral surface area. And you can't put it under surface area because you saw the word lateral surface area. You probably might be wise enough to know that. Here is the difference. They're very similar, except lateral surface area is the same as surface area, comma, without the area of the bases. Okay. Or you could also say surface area is just the sides. No top, no bottom. And it might help if we, oh here, let me draw you a shape here. Here's where things are going to get really wickedly good. Here is my shape. We have to go with a 3-dimensional L. Unfortunately, we talked about this. Did we draw? Did you guys get to draw the? Let's say these are the dimensions of our shape. This is going to take a little bit of time here. Let's do inches again. 4 inches, 5 inches, 5 inches. What is this? 9 inches. How high is this thing? Let's make it 4 inches. How wide would it be from here to here? Let's go 6 inches. Let's do 6 inches. So that would make this side how long? Anybody? 5 plus 6. 11 inches. Okay, so here's the deal. Okay, first of all, what is the shape of the base? We talked about this, the grand loaf of bread theory, Charlie. What shape is the base? An L shape. Okay, so if you're looking for lateral surface area, how many sides are going to make the lateral surface area? You've got this one, you've got this one, you've got this one, you've got this one, and then behind here where you cannot see, there is 2 more shapes. You got this back side over here, which would be side number 5, and you've got side number 6 there. So you're going to have to find the area of all 6 of those, and I should have done it with different colors. Maybe I will. That's the beauty of the board here. The beauty of the board here is this. Hey, Mrs. Nolan, 1, 2, 3, 4, 5 would be back here that you can't see, and 6 would be back there that you can't see. So here we go. Did I miss one?
Would you count the top and the bottom?
I would count the top and the bottom, except that I think lateral surface area is just the sides. Did I not mention that? Did I say just the sides? I thought I said that. Same as surface area without the area of the two bases. Now remember, there are two bases there. There's going to be two. So if you're doing lateral surface area, here are our dimensions. Side number 1 would be a 4 by 4. Boom. Side number 2 would be a 5 by 4. Side number 3 would be a 5 by 4. Stop me if I'm going way too slow. So area side number 4 is 6 by 4. Area number 5 is how long? 9 by 4. And side number 6 is a 11 by 4. Now, ladies and gentlemen, I'm hoping that at some point we have an aha moment here. I don't know what happens. Let's just do the quick math here. 4 times 4 is 16, 20, 20, 24. What was that, 9? 36 and 44. Add them all together and the lateral surface area is, what is that? 12, 16, and 10, 26. Did I get that right? You feel free to stop me. 8, 9, 12, 166. Am I close on that? Has anybody found along with the pattern here? Inches squared. Are you with me on that? Does that sound right? Brady, did I make a mistake? Tell me now.
I got 160.
I got 160. All right. I added wrong?
It's 2 6s 4.
Oh, I thought this was a 6. That's why. You're right. 160. I'm going to blame myself for that. Now, River's going to say, but maybe is there quite possibly a quicker way to do that? Yes, River. Thank you for asking this question. If you look here, look what happened here, children. What did I multiply everything by?
4.
4. Okay? Because of the whatever, the associative, whatever rule of this, a quicker way to do this, and here's a little formula for lateral surface area. Rather than doing that, and you can always do that, lateral surface area is the same thing as taking the perimeter of the base and multiplying it by the height. Which means instead of doing it all like this, do you remember that whole distributive property thing we talked about? I am really doing nothing but distributing out this 4. My height is 4 here. And what is the perimeter of the base? Well, the perimeter of the base is 4 plus 5 plus 5 plus 6 plus 9 plus 11. Remember the whole distributive property? We take 4 times this, 4 times that, 4 times that. So if I just add up all of these numbers first and then multiply it by 4, I am going to get that same thing right there. Let's see what happens. 9 plus 11 is 20, 31, and 9 is 40. What is 40 times 4 but 160? So if you're asked for the formula for lateral surface area, this is it. But it is, as Ephraim will tell you, the area of all the sides without the bases put together. Now, here's something to keep in mind. Something to keep in mind, Leah. When you find regular surface area, you still have to find the lateral surface area because that's part of the whole thing. But if I know the lateral surface area, what can I do to find total surface area? I just need then to add the 2 bases onto that, right? You with me? If I know that 160 is all the sides, I just need to add the top to that and the bottom to that, and that's total surface area. So what would be the, let's just do it real quick. Let's say I cut this shape like this. What's the area of this base right here? This part right here is 11 times 4. This is 44. What is the area of this little rectangle right here? It would be 5 times 6, which is 30. So I have, what for my thing? 74 would be the top, and 74 would be the bottom. If I add those together, that would be total surface area. Are you kind of with me on that? These are all things that you will get more and more confused with, Charles, as we go along. No, it'll come a little bit more to that. Just remember, from that lateral surface area is what? Just the sides. Like if I wanted to paint my classroom, I'm not going to paint the ceiling, and I'm not going to paint the floor. So for me to figure out how much paint I need to paint the walls, I would use the lateral surface area of it, because I'm just painting the sides. Of course, then you got to exclude the windows and the chalkboard and the counter and the doors and all that. It gets to be a kind of a complicated sort of thing. But it is nonetheless